these next two sections go together, 7.5 and 7.6. 7.6, the next section after this, is identical to this section, so you have to get this. It just adds on one more criteria. So systems of inequalities. We want to be able to solve these inequalities by graphing. So we're going to take the XY plane, graph each of the inequalities, and then find the cross section of the shaded region. Where the regions cross, that intersection is said to be the solution. So here the solution for the system of inequalities will not be a point, which was our goal for systems of equations, but systems of equalities, the solution would be a region, would be an area. And so we'll show you that. Here we only do it in two variables. So one thing that you want to recall for inequalities is that when you are multiplying or dividing both sides of the inequality by a negative number, make sure that you reverse the inequality sign. Do you remember that? Okay, good. So example there, if I have negative 2x is less than, let's say, 10, and to solve this inequality, I divide both sides by negative 2. So here x is greater than negative 5. Here we divided both sides by a negative number, and in doing so we reversed the inequality sign. We went from less than to greater than, right? So that's important. How do we solve these systems of inequalities? Here I start with the linear inequalities. So what we're going to do here is for each equation, we're going to solve for y. It may say y less than, y greater than, but you look at it as just y equal to for starting out. And then you take that y equal to some mx plus b, which is a straight line, graph that straight line. If it says y less than, then that means that you're going to shade in everything under the line. If it says y greater than, then you're going to shade in everything above the line. So those are steps 3 and 4. So if it's y less than, everything under the line. If it's y greater than, everything above the line. If it's less than or equal to, it's going to be a straight line, but if it's just less than or if it's just greater than, you'll have to pick in my math lab for the dotted line. The solution will be the cross section of all the regions. Well, sometimes you may have also not just linear inequalities, but you may have nonlinear. You may have, here is an example of a quadratic. Matter of fact, let me go back here and just give an example of, let's say, 3. This is an example. 3 is y less than. So let's say, for example, if I have a straight line that I just got through graphing, and since it's for 3, it says y less than, then that means that we're going to shade in everything under the line. Okay? So that whole region there would be the solution for y less than or equal to mx plus b. And then an example of 4. Say, for example, if we have this line, and here it says y, for 4, it says y is greater than, so I'm going to shade in everything above the line. Okay. Does that make sense? Okay. So y greater than, for lines, y greater than everything above the line, y less than everything under the line. Now, if you get confused in terms of what's above or what's under, just take the line and act like you have an imaginary ball and put that ball on that line. If that ball continues to stay on top of that line and slide down, you know you're on top. If that ball, imaginatively, falls straight down, then you know that you're up under the line. Okay. Here, if it's a quadratic, now it doesn't have to be as fancy as ax squared plus bx plus c. It may be something like this. It may be y is just less than, let's say, x squared, or 5x squared. Doesn't have to be, as long as you know that you can identify that it's a quadratic. If it says y less than, then that means we're going to shade in everything below or basically outside of the parabola. You remember the parabola? How can we forget it? So here, y less than. Think about it. Y less than would be everything out here. So everything on the outside. Not say that everything below or everything on the outside of the parabola. So my word here, wording below, is misleading because it's just not everything below, but that should be everything on the outside of the parabola. And I'm sorry about that. Good morning. So here, if I take just the basic example, y greater than, and just say equal y greater than or equal to x squared. So I have the parabola, and so y greater than is everything inside the parabola. Well, there you go. Oh, this is x less than y squared. And that parabola goes sideways because it does this. So x less than would be everything on the outside. So basically going back to negative infinity. So that's going to capture all of and then if it's x greater than, you don't have anything like 3 and 4. There is one on the quiz that does something like 1 or 2, numbers 1 or 2. So here, this is x greater than, so that's x going into positive infinity. So that's going to be everything on the inside. All right. What if you have a circle? You will have some possibilities, some problems where you have a circle. So if it says x squared plus y squared is less than r squared, that means that you're going to shade in everything inside the circle. And if it says x squared plus y squared, this is point number 2, greater than r squared, that's everything on the outside of the circle. So less than here means everything on the inside of the circle. And then x squared plus y squared greater than everything on the outside. The cool thing is that once you, in my math lab, once you have that region, it'll be contained, then you'll click on where it says like pour in paint, and it just shades it for you. So you just put the clicker on, or the cursor on the area, and it does the shading for you. All right, so let's start with this one, and again, we're going by the steps. What steps are they? Let's go back. Those steps there. Solve in here, parentheses, linear systems of inequalities, steps 1 to 5. So let's look at this problem. So I'm going to take each inequality and just get y by itself. So for that first one, I have 8y is less than or equal to negative 4x plus 8. Now I'm going to divide both sides by 8, so I get y is less than or equal to negative 1/2 times x plus 1. Okay, we'll just call that equation 1, and that'll correspond to line 1 once we graph it over there. Do the same thing for this guy. Let's get y by itself. Well, that y, that's easy to get. We just subtract 2x on both sides. So I have here y less than or equal to negative 2x plus 8. So we'll call this equation 2, excuse me. That'll correspond to line 2. All right. So now the next step is to graph each of the lines. So, and even though it is inequality, I got equation. Equation means equal. So let's just go ahead and say it. Equation 1, is y equal to negative 1/2 x plus 1. And then equation 2 is y equal to negative 2x plus 8. I got to draw the lines first. So for equation 1, we're going to use the method that we had talked about back in chapter 1. That is, we have the equation, it's a line equation, and we have it in what's called, you remember, slope-intercept form. So look, we put it in the form y equal to, and I know it was a while ago, and you've been through so much in this class. It's like boot camp, you know? It's just so much. So this is slope-intercept form. You remember that number m is the slope. That number out there by itself is the y-intercept. So we can graph just based on that concept, and that is for equation 1, my y-intercept is 1. So I'll put a dot here on 1 on the y-axis. The slope is negative 1/2. You remember that means go down 1, go over to the right 2. From a point, the point that where we are is this y-intercept. So I'm going to go down 1, I'm going to go over 2, I'm here. Then I'm going to draw a straight line. So now, this says, for that equation 1, it says y less than. So I'm going to shade in everything under this line. Okay. So now let's go to equation number 2. So equation number 2, the y-intercept is 8. And then here, the slope, I want you to see it, this is negative 2/1. So that means go down 2 and then go over to the right 1. So go down 2, 1, 2, and then go over to the right 1. Now we draw a straight line going through these 2 points. And the cool thing in my math lab, it's those lines are more accurate than just straight hand, or for me, crooked hand, you know, like crooked letter, humpback. Anyway, so I need to label this. This is line 1 and then line 2. So line 2 says everything under it. Now for line 1, let me make sure I get everything there. And now let's go to, for line 2, everything under it. Let's use a different color for the highlighter. So this is everything under line 2. Now, the region that's the solution, because here for systems of inequalities, the solution is not a point, it's a region. So the region is said to be the cross section, where those colors cross. That becomes the solution. So if you see it, is where the yellow and the red where they intersect. That's what all we want. So I don't know if I put the graph on the next page. Oh yeah, I am really smart. See that? That's that cross section. Let's go back. See that cross section is where those 2 colors cross. Now check this out. In my math lab, when you draw those 2 lines and then you go to pick like the shaded area, it'll be like a cup, like you're pouring paint or something. You click that, and then you take your clicker and you just click anywhere over here. It's going to shade that region for you, okay? Because what the computer is recognizing for a graph like this, for this particular problem, the algorithm is recognizing 1, 2, 3, 4 areas. It's recognizing 1, 2, 3, 4. If you put the clicker here for the cup, it's going to shade this, but you don't want that. If you put your cup there, it's going to shade that, but you don't want that. You can just put that image right there. Anywhere over here, it shades it for you. You're done. Okay. That's pretty cool. Is that okay? Let's look at another one. We don't get it until we get it, right? All right. So again, and if you go back to those steps that I have on, on a few pages ago, that's exactly what we went by. So again, take this inequality, we're going to get y by itself. Subtract 2x on both sides, so I have negative 6y less than or equal to negative 2x plus 12. Now I'm going to divide both sides by negative 6. Now dividing by negative, you remember for inequality, reverse the inequality sign. So this is y, this becomes greater than or equal to negative 2 divided by negative 6 is just 1/3 times x, and then that's 12 divided by negative 6, negative 2. So we'll say equation 1 is y equal to 1/3 x minus 2. I mean, while we're there, let's just go ahead and just graph that guy. So the y-intercept is negative 2. On the y-axis, negative 2. The slope is 1. That means go up 1 over 3. Go to the right 3. So I go up 1 and go to the right 3. 1, 2, 3. So now I draw a straight line. Missed it. That was a good straight line, though. All right, that's going to have to do. So we call that line 1. And this line 1 is y greater than. That's everything above. Okay. So now let's do the second inequality. So here, subtract 3x on both sides, so I get negative 2y greater than negative 3x plus 6. Now divide everything, both sides, by negative 2. And don't forget, since we're dividing by negative for inequality, reverse the inequality sign. This is y less than 3 over 2 times x, and then that's minus 3. So let's pick a different color to graph this guy. Equation 2 is y equal to 3 over 2x minus 3. So here for negative 3, that's the y-intercept. So I go down to negative 3 on the y-axis. And then the slope says go up 3, go over to the right 2. So go up 3, 1, 2, 3, go over to the right 2. I'm here. Connect those two. This is line number 2. Now line number 2 says y less than.
Would that one be dotted?
It'll be dotted, yes, because it's not less than or equal to. You're exactly right. Messed up a perfectly good straight line, but thank you. Oops, wrong one. Very good. Yep. And then that's y less than. So everything under this line, right? And the cross section would be that, just this section, and I draw that with a different color. We use this dark one. It's that canal. 16 miles on the Erie Canal. Yep. Okay. Okay. How's that? Does it make sense? Okay. Thank you, Maggie. Good old Maggie. All right. Why don't you try your hand at that one? Now, I did the first step for you for that problem. Y is already by itself. So, you got to give me a pat on the back for that. Let's see what you get. And I won't work it out. I'll just give you a couple minutes and I'll just click to the next page to see if you got the right graph, okay? Is that what you got? Okay. Good deal. Good deal. All righty. All right, all right, here's one that involves a circle and a line. So that x squared plus y squared less than or equal to 49. Since it's less than, then that tells us back from the previous instructions that we're going to shade it and everything inside the circle. And then we have the line down below with the inequality that represents the line. Let's see. So from this one, we have x squared plus y squared. We'll look at the line. This is equal to 7 to be squared. So the radius is 7. And the center is at 0, 0. Right? You remember the formula for the circle is x minus h to be squared plus y minus k to be squared is equal to r squared. Well, h and k are 0, so that's why we just have x squared plus y squared equal here to 49. And then for the line, we have y is less than negative x plus 5, and so we look at y equal to negative x plus 5 to draw the line. So we can start with the circle. So the circle is the origin, the center is at the origin, and then the center origin, the radius is 7. So I'm going to just hit all the points 7, radius 7 on my graph. So that's everything on the inside of the circle. Let's go ahead and get this equation 2. Equation 2 is y equal to negative x plus 5. So the y-intercept is 5. The slope is negative 1 over 1. So go down 1, go over to the right 1. And then we draw a dotted line. I know it's a rough looking circle. It looks like a rhombus, not a circle, right? Yeah. Drawing is not the best. Yeah. Probably didn't do any better. So this guy is y less than. So that's everything under the line and inside the circle. So we can go ahead and just get the cross section right here. So inside the circle and under the line. All right. That's a better circle.